Okay, time for our next speaker. Final one of this section, then we'll get together and get into the nitty-gritty of all this stuff, which I'm looking forward to. So we got Stu Cox. He's a developer at Potato, and he also works on Modernizer. You may have heard of it. And you might notice a theme throughout today, and Stu is going to tackle it head on right now, because he's going to talk about fighting fragmentation. So why don't you give him a great big welcome. Stu Cox, ladies and gentlemen.
Currently having a bit of trouble actually signing into my laptop because I can't see the screen, which is lovely. Can I get my screen up on the slide? There we go. Watch me type in my password, everyone. There we go. Live demo of entering a password. Right. Thanks. So, yes, I'm very aware that quite a few of you are not going to like what I'm about to say. This talk kind of has a few different agendas. One is to try and introduce a bit of balance. Another is to kind of try and walk a bit of a middle path between some of the kind of philosophical stuff that we heard at the start and these kind of very implementation-specific details that we've just been learning about. And I guess try and find, what's the kind of linking route from a philosophy where we're trying to support as many users as possible and the actual day-to-day implementation. I make websites. I spend a lot of time like hacking around in code and all this kind of stuff. And being able to do that quickly, efficiently, and reliably is very, very important to me and to my clients. So when I refer to tiered JavaScript apps, by that I just simply mean that different users get different experiences. I think just about every website, whether intentional or not, gives different users different experiences. And obviously, we want to control them to some extent. And the title here, Fighting Fragmentation, just simply refers to the fact that tailoring for more users means that we naturally end up fragmenting those user experiences and ultimately the code path that I have to write. So if we just take a really simple user journey, let's say this is an e-commerce site. Someone lands on the homepage, they search for a product, they read the description, they add it to the basket, and they check out. Simple, right? But actually, this could be experienced in so many different ways. On the homepage, you can have different layouts of different glass sizes. Some users might be viewing the images, others might be reading alt text. You might be serving WebP images to browsers which support it to improve load times. On the search side of things, maybe the search bar is hidden in a nav, in a hidden nav sort of behind a burger menu or something on a small screen. You need to consider all different input types. People might be tabbing, tapping, clicking, or talking to enter their search. And it might function differently offline. Description might also work offline. You have to consider how assistive technology and search bots are going to view it. You might have something like a 360-degree view that's been rendered with WebGL if you're proper future. The add to basket step, you might want to submit asynchronously. Some users might not experience that. You might have some kind of UI frills, things flashing when they appear in the basket, these sorts of things. And then when we get to the checkout, the date widget on my phone is hugely different from the one on my Mac. Firefox doesn't have one by default. Do we have to polyfill it there for those users? Whether or not we validate in the browser might vary depending on browser support, and autocomplete as well. All of these things together actually give us thousands of different journeys that could happen through this single user flow. And I kind of, I don't want to have to start thinking about like a non-JS version of a searchable select box in the form. Like, I've got enough to worry about as it is here. It is literally, there are thousands of different ways that just this one user journey could pan out, and I don't want to have to spend my time testing them all. This increased multiplicity, it's more to design, it's more code for us to write, it's more to test, and there's more to go wrong. We're just creating more and more work for ourselves, potentially for very good reasons. I want to sort of suggest some ways to tackle this, but in order to do that, I kind of want to make sure you're all on the same page as me. So I kind of promised I wasn't going to do any soapboxing in this talk when I was talking to the organizers, but put me on a little stage. I've got like a laser pointer. Okay. The next 3 minutes is going to kind of be a cross between Sesame Street and A Beautiful Mind. So we have features which depend on capabilities. That's kind of fairly obvious. Capabilities might be capabilities of the browser, the HTML5 features, CSS features, JavaScript language features and APIs, plugins and extensions, and bugs, which are incapabilities. You have device capabilities, screen size, input-output devices, sensors, network quality, portability, those sorts of things. And you have the capabilities of the human using it. Their eyesight, their hearing, their coordination, cognitive function, technical knowledge, the languages that you speak, your attention span, and so much more. I refer to these three together as it's the user, kind of holy trinity. Features we can define as either being core functionality or enhancement. Core functionality should be things that you expect every user in your target audience to experience. Enhancements, well, we know that word. Another way of looking at it, let's say we have a set of capabilities here. So some belong to the browser, some belong to the device, some belong to the human. And we have a set of features, core and enhancements. And let's take an example feature. So a core feature might be your article. That might depend on the browser's ability to convey text, the device's ability to access the network, and the human's ability to understand English if your article's written in English. We can represent those dependencies between the feature and its capabilities. Obviously, this is a simplified view. In reality, there could be a huge number of different capabilities involved in this. If one of those capabilities is missing, then that feature isn't going to be experienced. Capabilities that your core features depend on, you can consider hard dependencies. If a user lacks one of your app's hard dependencies, it's not great. They're likely to feel alienated. They're not going to get the content. And to me, this is just, I guess, one way of framing and thinking about accessibility in a broad sense. There's obviously a lot more to accessibility than this, but I believe that pretty much any accessibility problem, which includes browser support, it includes device support, can be thought of in terms of features that are depending on capabilities that may or may not be there. So another example, let's say an enhancement is a product photo. Depends on the browser's ability to render images, device's ability to display graphics, and a human sight, maybe. Again, if a capability is missing, then it won't be experienced. But that's fine because this is an enhancement. This is effectively another way of looking at progressive enhancement, or just another way of picturing it in your mind. So another example, slightly more nuanced now. Let's say we have the enhancement we talked about earlier of having a 360-degree product view on your description page. It too has a set of dependencies, let's say WebGL support, and then displaying graphics again and the human being able to see. Again, here's the mapping of features and the capabilities they depend on. And if a capability is missing, that enhancement won't be experienced. But what if the feature is left half complete by that capability not being there? It doesn't just mean that it doesn't just mean that the feature vanishes because the capability isn't there. It's where things kind of can get a little bit crazy, and in the kind of day-to-day work of a developer, these are the situations that we really want to avoid. Just a quick example. Here's a page to do with Google's Project Tango, where they have a WebGL little kind of 3D thing that you can drag around. It was just the first example I could think of a 3D view or something. And along the top there are some HTML buttons. If WebGL is not supported, then, OK, the WebGL won't show up. Fair enough. Not a massive problem. But those buttons are still at the top, but they mean absolutely nothing to a user. Atomic enhancements is the term that I use for features, or specifically enhancements, that don't fall into this trap. They're never partially applied, and these are really, really good. You can also interpret this as a kind of more literal sense of the term graceful degradation, but hopefully without the evil connotations that we've all been told that we should associate with that term. So back to this capability diagram, how can we make sure our enhancement is atomic? Feature detection. We check that all capabilities are present before we render the enhancement. Most browser features can be detected. I'm probably going to eat my words when someone actually shows me some numbers on that, but obviously Modernizer, which I've been a core contributor of for a while, provides a huge library of different ways to detect browser features. Device features, some of those can be detected, some of them not so much. And for a human, well, maybe you just need to ask. But when your feature detection says no, what can you do? Option one is to just simply not show that feature. You only deliver the enhancement if the capabilities are met. That's really easy because we kind of only have two states to build, or to design, build, and test. Option two is providing a polyfill or a fallback. Realistically, a polyfill or fallback is just an alternate enhancement. You could consider it completely independently. Or option three is to implement it another way. Use some less demanding dependencies. You can obviously see that routes 1 and 3 there put the least stress or onus on the designers, developers, and testers. That's the theory, at least. Let's talk about JavaScript. JavaScript's just one of many, many, many capabilities that we might depend on for various different things. Think back to that, the rows of capabilities along the bottom and our features along the top that we're trying to support. JavaScript is just one of those boxes, and I was massively simplifying that anyway. So why is there such a focus on JavaScript when we talk about progressive enhancement? I don't think there really needs to be. That doesn't mean that I am a massive proponent of single-page apps and huge monolithic frameworks and all this kind of thing. I think that they have huge downsides in various areas. Examples about them not supporting the back button properly and this kind of thing, and being a massive page weight. I think those are big issues, and those are issues that JavaScript frameworks and the people who use JavaScript heavily need to solve. But I don't think we need to throw the baby out with the bathwater. To me, progressive enhancement doesn't mean that it works without JavaScript. I think most people in the room probably agree with that, but there's this ongoing flow as people talk about it. It's, oh, well, this isn't progressively enhanced because if I turn off JavaScript, it doesn't work for me. I think there are loads of reasons why it might make sense for JavaScript to be a hard dependency. Things like managing content loading, avoiding code duplication, and all these sorts of things. But again, that doesn't mean that the approach of providing enhancements based on certain capabilities when they're available, but then also having your core functionality that works effectively works for all of your target market. I think that that's still a very, very valuable pattern and something we can lean on. So one thing I kind of feel that I should just run through now is I'd actually already written this slide before Nat did her talk, and she went through some of these issues with JavaScript, reasons why using JS might not be particularly reliable. And I kind of want to go through these and realistically, I don't actually really agree with all of these, or I think that if you're planning to use and rely on JavaScript, then there are ways that you can try and address these. So first of all, bugs in developers' code. It's kind of a bit of a cop-out answer, just say test it better. But realistically, you can easily have bugs in your CSS. You can have bugs in your HTML. Yes, JS bugs might be slightly more catastrophic. But that also doesn't mean that if there is a bug in your JS for an enhancement, that it still won't completely knack your page. It could easily do that. So I don't think it's kind of, oh, if JS is only an enhancement, then the page will be fine if something breaks. It could still absolutely mess everything up. Third-party code. So the idea here is that adds and sharing widgets could break the JavaScript running on your page. One option there is to restrict that to an iframe. I think there are very, very good security reasons why you might want to do that anyway. Content could be blocked or modified by a firewall or your ISP. HTTPS and content security policy can stop intermediaries from messing around with your content. Again, very strong security reasons why those could be a good idea. Network issues. Again, I think if you're finding that part of your app isn't ending up in your users' browsers, then that's the thing to tackle, not go, oh, well, maybe it was the JavaScript, let's leave that out. Reduce your page weight. Think about inlining your CSS and JavaScript to reduce the number of requests. Maybe consider offline rendering like we've just heard. CDN outages. Again, if you think that that's really going to be a danger, then serve all your assets yourself. Again, security reasons why that can be a really good idea as well, depending on the CDNs you're using. Obviously, I appreciate the term CDN could refer to a company's own CDN system, like the Guardian used that I believe Ollie was describing earlier. This suggestion earlier of not enough RAM. In most pages I visit, or at least a lot of the glossy marketing stuff I see, the images are much more likely to use up all my RAM rather than the JavaScript. Again, reduce your page weight. That's the thing to tackle, not just throwing out the JavaScript. Browser plugins. So yeah, these last two things are kind of a little bit harder to protect against, I think. Yes, a browser plugin can completely break your JS. It tends to be fairly sandboxed in most browsers, but still, your HTML and CSS are just as vulnerable. It's, you know, the quote earlier about how wild a world the web is. This is kind of the reality of it. And there is realistically a point where you just kind of have to say, if the user's installed a plugin that breaks pages, then the user's installed a plugin that breaks pages. And again, if specific assets are being blocked by a browser extension, either that's intentional, they don't want scripts, or it kind of becomes anyone's guess what will and won't be blocked. So again, maybe a bit of a cop-out answer there. But I kind of don't feel that, like, if the things on the left can really concern you, then I'd consider the things on the right before trying to work out how you can build your apps without JavaScript. Great. That's just going to stay there, probably. You can piss right off. Try tonight. Yeah, great. Thank you. Right. So back to what we were talking about earlier. How can we kind of go from these stupid ideas that are shaking around in Stu's head to something that might actually be useful? How can we actually use that to make developers and maybe even designers' lives easier? Here was the user flow that we had with all of the different variations in that flow. One of the first things to do is kind of, let's get into that mindset. Let's think about features rather than differences. Kind of token effort there to kind of refer to using good use of a large screen rather than necessarily just thinking about it being responsive design. Things like the search bot view, the feature there is making it easy to find, these sorts of things. So slight shift in the way that you think about what you're putting together. I also think the code structure and the way that we approach our code really affects how we test it, how we think about it, how we talk about it. And one really simple place to start is to think about the way that your repo is structured. Here's an idea of how you could potentially structure your repo by focusing on the features being modules, rather than, I have kind of this component over here, thinking about how it's delimited in terms of the DOM, thinking about it as a tangible user feature. So by separating core functionality and enhancements very literally in your code base, you get a few kind of benefits out of this. If you want to see what the experience is like without voice input, you just delete the folder, give it a go. These sorts of things could be really, really helpful. It also makes it easy for someone new to the project to see the kind of enhancements that you have, and they can very easily see how the app is going to be built up from these different layers. Another way to do it, if you are working with a fairly modularized app, might be to actually have enhancements within your individual module folder. So it's a similar sort of structure, but maybe kind of flipped around the other way. Again, you could quite easily write a script that just excludes modules at random when you're testing. Again, when working at component level, it's very easy to see the different versions of each of these modules. Declaring your dependencies. If we're kind of thinking in terms of features and the capabilities that they depend on, then everyone who's working with your code should understand what those dependencies are. Easiest way, have a README. Just write some notes. Just say, OK, for this particular module, this is what it does, and these are the dependencies that we assume. You could obviously, I could have gone on for ages with that, kind of talking about the human side of dependencies as well, which I think are also very important. Maybe codifying things a little bit more. Again, using feature detects. If you wrap entire modules in a feature detect, then you know that that entire module will either be applied or will not. It's atomic. And if this is effectively kind of wired into the way that you structure and talk about your code, then I think it makes things a lot easier to reason about how layers are going to be applied or not applied for different users. A kind of JS example, as I say, I'm kind of not a sort of massive framework advocate. I've kind of used Angular as an example just because it componentizes things quite well. And I think it sort of gives you some encapsulation. So again, here's just an example of having an enhancement module where the entire module would be wrapped in a feature detect in order to make it atomic. Here's another way or a way of improving that is by actually taking those capabilities out as a dependency. So Angular has dependency injection. If one of our dependencies is our set of capabilities, then we both have atomic code, but then we can also mock out what those what capabilities are being represented in tests and even when we use testing in the browser. Back to the example about having a fallback and what I said about thinking about a fallback as simply being an alternate enhancement. Here's an example where I've just simply inverted the feature detect set there, and then again, it's another atomic enhancement. Another thing that this is kind of it's time for proper pragmatism, I think. And I think when you're trying to get stuff out the door quickly, when you're working with confined budgets, confined timescales, you do kind of have to cut some corners and you have to be realistic about things. And one way to do that is to kind of start grouping features together. Now, we kind of need to be careful here, right? So if we start off by going back to our set of features and enhancements, I've highlighted a few there that we could consider to be one particular tier. Okay? They actually have very little to do with each other. But by grouping them together, we can test through those different variations, once as having that tier, once as not having that tier, and we've only had those two different cases to consider rather than effectively a Boolean present, not present for every single one of those different features based on the capabilities that they require. So in order to do that, we might want to structure our code accordingly. So we have our core, and then our enhancements are separated into different groups. One kind of side thought to this is, for this to really be effective, you're probably going to want to start grouping things that sort of tend to appear together on certain browsers. So the kind of obvious example here is this sort of top shelf. Not to put any other browsers down, but voice input is currently in the browser only available in Chrome and Opera. So and they support WebGL as well. So that's kind of part of the motivation for that. Now I'm not suggesting we kind of go back to here's the Chrome version, here's the Netscape version, all this kind of stuff. It should still be completely feature detect based. If Edge adds support for voice input, it already has WebGL support, then those users will then automatically get the top shelf functionality. So again, just ideas to try and reduce the amount of cognitive load on people who are trying to create these kind of tiered apps. I know that nothing I've said here is probably particularly shocking or original or new. Maybe just wording things that you already knew in slightly strange ways. But I think this is kind of part of the point. I think we've got a huge amount of experience behind the community. We've all got different ideas about best practices and all this kind of stuff. And I think maybe just turning that very slightly through 10 degrees and just kind of thinking about things very, very slightly differently about how we can make those best practices more pragmatic and more applicable day to day, I know will make my life easier and hopefully make our users' lives easier too, because hopefully we'll give them fewer bugs. So I'm just going to kind of skim through the things I've just said. Having many tiers to a web app, you need a logical approach. For me, the model of features being defined in terms of dependencies and their capabilities, that makes a lot of sense. And I think it's a good model to think about and draw up the way that you're thinking about your tiers. Structuring your code, I think, is a really good place to start. It's not the be-all and end-all, but that kind of slightly different framing, it's a good way to convey that to yourself, again, to reiterate, and with the members of your team. Again, enhancement should be atomic, and I think your code should represent that. This is why I'm advocating entire modules that are either enabled or disabled based on capabilities. And I think all of this helps things to become easier to test and easier to decide where to cut corners, where can we group experiences together so there are fewer user journeys that we have to design, create, and test. I didn't really intend to finish on the suggestion we should just cut corners, but maybe that's the real message. Anyway, that's all I have to say, and now I think Jeremy has a box of rotten fruit he wants to throw at me.
Come on up, folks.